October 14th, 1918. The Argonne Forest, France. At 0547 hours, Oberleutnant Klaus Brenner peered through the morning mist at the American trenches 200 meters away, confident that his machine gun nests and reinforced positions would repel another futile assault. What he witnessed in the next 47 minutes would shatter every assumption German High Command held about American fighting capabilities, and introduce a weapon so devastating that it would be banned by international treaty within a generation. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The distinctive rapid-fire thunder that erupted from the American lines was unlike anything the German defenders had encountered in 4 years of mechanized warfare. It was not the methodical chatter of machine guns or the precise crack of rifles, but something that sounded like the very gates of hell opening in rapid succession. The Winchester Model 1912 trench gun had arrived on the Western Front, and with it came a tactical revolution that would transform close-quarters combat forever. Brenner commanded the 3rd Company of the 157th Infantry Regiment, battle-hardened veterans who had survived Verdun, the Somme, and countless smaller engagements that had decimated lesser units. These men understood warfare in its most brutal forms and had developed defensive tactics that had stopped British, French, and Russian assaults for years. They possessed superior defensive positions, overlapping fields of fire, and the psychological advantage of holding fortified ground against attacking forces. The German defensive doctrine had been refined through years of attritional warfare into a science of death. Machine gun positions were carefully sited to create interlocking fire zones that no infantry assault could penetrate. Barbed wire obstacles channeled attacking forces into predetermined killing fields. Artillery observation posts called down precise fires on predetermined target areas. The coordination between these elements created a defensive capability that exceeded the sum of its parts. The 157th Infantry Regiment had been positioned in the Argonne sector specifically because German High Command considered it one of the most defensible positions on the Western Front. The dense forest provided natural obstacles that channeled attacking forces into narrow corridors. The rolling terrain offered excellent observation and fields of fire for defensive positions. Most importantly, the sector had been fortified continuously for 4 years, creating defensive works that rivaled the strongest positions along the entire front. Brenner's company occupied a position known as Höhlenschlucht, or Hell's Gorge, a natural ravine that had been transformed into a defensive fortress through months of engineering work. Concrete machine gun bunkers were positioned to provide mutual support across the ravine. Communication trenches connected all positions to enable rapid reinforcement and supply. Underground shelters provided protection from artillery bombardment. The position appeared impregnable to conventional assault methods. The American forces preparing to assault this fortress were elements of the 79th Infantry Division, specifically the 2nd Battalion of the 314th Infantry Regiment, under the command of Major William Harrison. These troops were relatively new to combat, having arrived in France only 3 months earlier. However, they possessed equipment and training that represented the most advanced infantry doctrine developed during the war. Among the weapons carried by Harrison's assault troops were 12 Winchester Model 1912 trench guns, pump-action shotguns specifically modified for combat use. Each weapon was equipped with a 20-inch barrel, improved ejection system, and bayonet lug for close-quarters fighting. More significantly, these weapons were loaded with military specification buckshot rounds that contained 9.33 caliber lead balls per cartridge. The tactical doctrine for employing these weapons had been developed through careful study of trench warfare conditions and the limitations of existing infantry weapons. Traditional rifles were accurate at long range, but slow to reload and ineffective in close quarters. Machine guns provided high rates of fire, but were heavy, required multiple operators, and were vulnerable to counter-battery fire. Hand grenades were effective in trenches but had limited range and required dangerous exposure to throw. The Winchester M12 solved these tactical problems through innovative design and manufacturing that reflected American industrial capabilities. The pump-action mechanism enabled rapid follow-up shots without the complex reloading procedures required by bolt-action rifles. The large-bore ammunition delivered devastating stopping power at close range. The weapon's reliability under adverse conditions made it suitable for the harsh environment of trench warfare. Training with the Winchester M12 had been conducted at specialized facilities in the United States before deployment to France. Soldiers learned not only marksmanship, but also tactical employment methods that maximize the weapon's unique capabilities. Slam firing techniques enabled sustained rapid fire that could overwhelm defensive positions. Ammunition management ensured continuous firepower during extended engagements. Close-quarters combat methods integrated the weapon with traditional infantry tactics. The ammunition developed specifically for the Winchester M12 represented advanced understanding of terminal ballistics and wound mechanics. Military specification buckshot was manufactured to precise tolerances that ensured consistent performance and maximum effectiveness. Each round contained multiple projectiles that created a devastating pattern at typical engagement ranges. The psychological impact of these weapons often exceeded their physical effectiveness, as the distinctive sound and visible damage created fear among opposing forces. Sergeant James Mitchell of Company F, 314th Infantry Regiment, carried Winchester M12 serial number 347-892, a weapon that had been manufactured in New Haven, Connecticut just 6 weeks earlier. Mitchell was a 32-year-old veteran of the National Guard who had volunteered for specialized weapons training specifically to master the tactical employment of the trench gun. His experience with hunting and competitive shooting provided the foundation for developing combat proficiency with this new weapon system. The assault plan developed by Major Harrison reflected sophisticated understanding of German defensive tactics and the capabilities of available weapons. The attack would commence with a brief but intense artillery preparation designed to suppress rather than destroy German positions. Assault troops would advance in small groups using terrain features for concealment. The Winchester M12 teams would focus on eliminating machine gun positions that posed the greatest threat to the advancing infantry. German intelligence reports had provided warnings about American development of specialized trench warfare equipment, but these reports had been largely dismissed by field commanders who considered American forces inexperienced and poorly equipped compared to European armies. The concept of using shotguns in military operations was viewed as primitive and ineffective against modern defensive systems. Oberleutnant Brenner had received briefings about American tactical innovations, but his focus remained on proven defensive methods that had succeeded against British and French assaults. The German position at Hollenschlucht had been attacked 6 times during the previous year, and each assault had been repelled with minimal German casualties. Brenner had confidence in his men, his weapons, and his defensive plan. The morning of October 14th began with typical autumn weather in the Argonne Forest. Dense fog provided concealment for the American assault preparations while reducing visibility for German observers. The temperature hovered near freezing, creating conditions that would challenge both weapons reliability and soldier endurance. Artillery fire from both sides had been intermittent throughout the night, suggesting another day of routine skirmishing rather than major offensive action. At 05:30 hours, American artillery began the preparatory bombardment that would signal the beginning of the assault. The fire was brief but accurate, targeting known German positions with high explosive and smoke rounds designed to suppress rather than destroy defensive positions. German counter-battery fire responded within minutes, but the American batteries had already shifted positions to avoid retaliation. Sergeant Mitchell checked his Winchester M12 one final time, ensuring that the weapon was properly loaded and that his ammunition pouches contained the 24 rounds allocated for the assault. The buckshot cartridges felt heavy in his hands, each one representing devastating firepower that could change the outcome of close-quarters combat. His training had prepared him for this moment, but actual combat would test both his skills and his courage. The signal for the assault came at exactly 05:47 hours, when the artillery fire shifted to targets deeper in the German defensive zone. American infantry began emerging from their assault positions, moving forward in coordinated groups that had rehearsed these movements for weeks. The Winchester M12 teams advanced with the leading elements, prepared to engage German machine gun positions that posed the greatest threat to the assault. German machine gunners opened fire as soon as American movement was detected, sending streams of bullets across the killing field that separated the opposing forces. The distinctive sound of German MG-08 machine guns echoed through the forest as defensive fires were coordinated according to predetermined plans. Brenner observed the developing assault from his command position, confident that his defensive fires would stop the American advance as they had stopped previous attacks. The first indication that this assault would be different from previous attacks came when American forces reached the German wire obstacles without suffering the catastrophic casualties that typically characterized infantry assaults. Small groups of soldiers with specialized equipment began cutting through the wire using methods that had been developed through careful study of German defensive systems. The advance continued, despite German machine gun fire that should have stopped any conventional infantry attack. Sergeant Mitchell's team reached the edge of the German trench system at 0603 hours, 16 minutes after the assault began. The Winchester M12 had proven its effectiveness during the advance, with Mitchell personally eliminating 2 German machine gun positions that had been causing casualties among the advancing infantry. The distinctive thunderous reports of the trench guns were creating confusion among German defenders who had never encountered weapons capable of such rapid and devastating fire. The close-quarters fighting that erupted in the German trenches demonstrated the Winchester M12's revolutionary impact on infantry combat. Traditional trench clearing operations required coordinated use of rifles, grenades, and bayonets in time-consuming and casualty-intensive fighting. The trench guns enabled individual soldiers to clear defensive positions with unprecedented speed and effectiveness. Mitchell encountered his first German defender at a range of 12 feet in a communication trench that connected 2 machine gun positions. The Winchester M12's devastating buckshot pattern eliminated the threat instantly, while the pump-action mechanism enabled immediate readiness for the next engagement. The weapon's reliability under combat conditions exceeded expectations, functioning perfectly despite mud, moisture, and the stress of rapid firing. The psychological impact of the Winchester M12 on German defenders became evident as the assault progressed. The distinctive sound of the weapons created fear and confusion among soldiers who had never encountered such power fire in close-quarters combat. The rapidity of fire possible with the Winchester M12 had overwhelmed German defensive procedures that had been designed to counter slower-firing conventional weapons. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The success at Hohenschlucht represented more than a tactical victory. It demonstrated that American industrial capability and innovative thinking could produce weapons that changed the fundamental nature of combat. The Winchester Model 1912 trench gun had been developed specifically to address the challenges of trench warfare, and its effectiveness validated the concept of purpose-built military equipment designed for specific tactical requirements. Major Harrison's after-action report emphasized the revolutionary impact of the Winchester M12 on assault operations and recommended immediate expansion of trench gun employment throughout American forces.
The weapon had exceeded all expectations for effectiveness, reliability, and psychological impact on enemy forces. The report specifically noted that traditional German defensive tactics were inadequate against American forces equipped with these innovative weapons. The German response to the Winchester M12's battlefield effectiveness would come in the form of diplomatic protests that would eventually lead to international restrictions on military shotgun use. The weapon's devastating effectiveness in close-quarters combat was considered so significant that German military leaders argued it violated existing international laws governing military weapons. These protests represented acknowledgement of the Winchester M12's revolutionary impact on infantry warfare. The 47 minutes of combat at Hollenschlucht on October 14, 1918, had demonstrated that innovative American weapons could overcome even the strongest German defensive positions. The Winchester Model 1912 trench gun had lived up to its promise as a revolutionary weapon system that would change infantry tactics and provide American forces with decisive advantages in close-quarters combat. Sergeant Mitchell survived the assault and would continue using his Winchester M12 throughout the remaining weeks of the war. His experience at Hollenschlucht convinced him that American industrial innovation and tactical thinking had produced a weapon that gave infantry soldiers capabilities that previous generations could never have imagined. The trench gun had proven that individual soldiers equipped with superior weapons could achieve tactical results that had previously required massive coordinated efforts. The story of the Winchester M12 at Hollenschlucht would become part of American military legend, demonstrating how innovative thinking and superior manufacturing could produce weapons that changed the balance of power on the battlefield. The German infantry, who had expected to repel another futile American assault, instead discovered that their opponents possessed weapons and tactics that rendered traditional defensive methods obsolete. The success at Hollenschlucht sent shockwaves through German high command that reverberated far beyond the immediate tactical implications. Within 72 hours of the assault, detailed reports reached General Erich Ludendorff's headquarters describing an American weapon system that had rendered 4 years of German defensive doctrine obsolete in less than an hour of combat. The Winchester Model 1912 had not merely won a single engagement, it had demonstrated capabilities that would force a complete reevaluation of infantry warfare principles. General Friedrich von Lossberg, the architect of German defensive strategy, received the first comprehensive analysis of the Hollenschlucht engagement on October 17, 1918. The report, compiled by surviving officers and interrogation of American prisoners, painted a disturbing picture of technological innovation that had outpaced German military thinking. Von Lossberg had spent 3 years perfecting defensive systems that could withstand conventional infantry assaults, but the American trench guns represented a paradigm shift that his defensive philosophy could not address. The technical specifications of the Winchester M12 that emerged from intelligence analysis revealed the weapon's revolutionary design principles. The pump-action mechanism enabled individual soldiers to achieve rates of fire that previously required crew-served weapons. The large-bore ammunition delivered terminal effects that exceeded traditional rifle cartridges by orders of magnitude. Most significantly, the weapon's reliability under combat conditions demonstrated American manufacturing capabilities that German industry struggled to match. Lieutenant Colonel Heinrich Weber, the senior intelligence officer responsible for analyzing American military innovations, submitted a classified assessment that would prove prophetic about the future of infantry combat. Weber's analysis concluded that the Winchester M12 represented the emergence of a new category of individual combat weapons that combined the firepower of automatic weapons with the mobility and flexibility of personal firearms. His recommendation for immediate development of German equivalent weapons would be ignored due to resource constraints and manufacturing limitations. The psychological impact reports from German survivors provided equally disturbing intelligence about the Winchester M12's battlefield effectiveness. Veteran NCOs who had survived years of combat described the panic and disorientation caused by the distinctive sound and devastating effects of the American trench guns. The weapon's ability to clear defensive positions with unprecedented speed had created fear among German troops that traditional weapons could not inspire. Major Wilhelm Hoffmann, who had commanded the reserve company at Hollenschlucht, provided the most detailed account of the Winchester M12's tactical employment during the American assault. Hoffmann described how small teams of American soldiers equipped with these weapons had systematically eliminated German machine gun positions that should have been able to stop any infantry attack. The coordination between traditional infantry tactics and the innovative trench gun employment had overwhelmed German defensive procedures. The manufacturing analysis conducted by German technical intelligence revealed the industrial implications of American trench gun production. The Winchester Repeating Arms Company had developed mass production techniques that enabled rapid manufacturing of complex firearms while maintaining quality standards that ensured battlefield reliability.
The integration of precision manufacturing with innovative design represented American industrial capabilities that German factories could not replicate under wartime conditions. Meanwhile, American forces throughout the Western Front were receiving their own Winchester M12 allocations based on the success at Hollenschlucht. The 1st Infantry Division received 48 trench guns for immediate deployment in the Meuse-Argonne offensive. The
The 2nd Infantry Division was allocated 36 weapons for operations in the Champagne sector. These distributions represented the beginning of systematic employment of revolutionary weapons that would change the nature of infantry combat. Training programs for Winchester M12 employment were rapidly expanded to accommodate the increasing number of units receiving these weapons. Specialized instructors who had combat experience with the trench guns were transferred to training facilities where they could share tactical lessons learned from actual battlefield employment. The curriculum emphasized not only marksmanship but also tactical integration of the weapons into existing infantry doctrine. Sergeant James Mitchell, now recognized as one of the most experienced Winchester M12 operators, was selected to participate in the training program development at the American Expeditionary Forces headquarters. His combat experience at Hellenschlucht provided practical insights that complemented theoretical analyses of the weapon's capabilities. Mitchell's contributions to tactical doctrine would influence American infantry training for decades beyond the war's conclusion. The ammunition production challenges associated with Winchester M12 employment required innovative solutions from American industrial capacity. The specialized buckshot cartridges demanded precision manufacturing that exceeded requirements for conventional rifle ammunition. Remington Arms Company and other manufacturers developed new production techniques that could meet the quality standards necessary for reliable military use while achieving the quantities required for widespread deployment. Combat reports from additional engagements throughout October 1918 provided validation of the Winchester M12's revolutionary impact on infantry operations. The 26th Infantry Division employed trench guns during the assault on Grand Pre, achieving tactical success that exceeded all expectations. The 77th Infantry Division used Winchester M12s to break through German positions in the Lost Battalion sector that had resisted previous attacks for weeks. The German military response to the Winchester M12 threat evolved through several phases as the implications of American technological innovation became apparent. Initial attempts to develop countermeasures focused on tactical modifications to existing defensive procedures. German units were instructed to increase the depth of their defensive positions to reduce the effectiveness of close-quarters weapons. Machine gun placements were modified to provide better protection against assault teams armed with trench guns. However, these tactical adaptations proved inadequate against the fundamental advantages provided by the Winchester M12's design characteristics. The weapon's rapid rate of fire and devastating terminal effects could not be countered through position modifications alone. German forces required technological solutions that their industrial capacity could not provide within the remaining time frame of the war. The diplomatic response to Winchester M12 employment represented German acknowledgement of the weapon's revolutionary significance. On November 3, 1918, the German government submitted formal protests through neutral channels arguing that military shotguns violated existing international agreements governing military weapons. These protests specifically cited the Winchester M12's effects as being unnecessarily cruel and exceeding the requirements of military necessity. The American response to German diplomatic protests was delivered through official channels on November 7, 1918. Secretary of War Newton Baker's statement emphasized that the Winchester M12 represented legitimate military innovation that provided tactical advantages without violating international law. The American position maintained that German objections reflected military frustration rather than legal concerns about weapon characteristics. The technical development history of the Winchester M12 revealed the innovative thinking that had produced such a revolutionary weapon system. John Browning's original design concepts had been refined through extensive testing and evaluation that considered the specific requirements of trench warfare. The collaboration between military experts and civilian manufacturers had produced a weapon that exceeded the performance of any existing infantry firearm.
Manufacturing documentation from the Winchester Repeating Arms Company showed the industrial mobilization required to produce military specification trench guns in quantities sufficient for battlefield deployment. The company had converted civilian production lines to military specifications while maintaining the quality standards necessary for combat reliability. This industrial achievement represented American manufacturing capabilities that European competitors could not match. The field maintenance procedures for the Winchester M12 demonstrated the weapon's practical advantages for military use. The simple mechanical design enabled soldiers to perform basic maintenance and repair procedures without specialized tools or technical training. This reliability under adverse conditions gave American forces significant logistical advantages compared to more complex weapon systems that required extensive support infrastructure. The training evolution for Winchester M12 employment reflected growing understanding of the weapon's tactical potential. Early training programs had focused primarily on marksmanship and basic operation. Advanced training incorporated small unit tactics that maximized the weapon's effectiveness in coordinated infantry operations. Specialized courses addressed urban combat, trench clearing, and defensive applications that went beyond the original assault mission. Combat effectiveness analyses from multiple engagements provided quantitative validation of the Winchester M12's revolutionary impact. American forces equipped with trench guns achieved casualty exchange ratios that exceeded historical norms for infantry combat by substantial margins. The speed of tactical success in assault operations reduced American casualties while increasing mission accomplishment rates across all operational contexts. The psychological warfare implications of Winchester M12 employment became apparent as German morale reports documented the weapon's impact on enemy fighting spirit. German units that had encountered American trench guns showed reduced willingness to defend prepared positions. The distinctive sound and visible effects of the weapons created fear that extended beyond their immediate tactical employment. Intelligence reports from German prisoners provided additional evidence of the Winchester M12's psychological impact. Interrogation transcripts revealed that German soldiers had developed specific fears about encountering American forces equipped with trench guns. These psychological effects multiplied the weapon's tactical effectiveness by reducing German defensive coordination and fighting determination. The strategic implications of Winchester M12 technology extended beyond immediate tactical applications. American military planners recognized that the principles demonstrated by the trench gun could be applied to future weapon development programs. The integration of rapid-fire capability with individual soldier mobility represented design concepts that would influence military technology development for generations. International military observers who witnessed Winchester M12 employment submitted reports that documented the weapon's significance for future warfare development. British and French military attachés provided detailed assessments of American trench gun tactics that would influence their own military technology programs. The recognition that individual soldiers could achieve unprecedented levels of combat effectiveness through superior weapons would drive military innovation throughout the post-war period. The final weeks of World War I saw continued expansion of Winchester M12 employment as American forces pressed their offensive operations against increasingly demoralized German defenders. The weapon's proven effectiveness in diverse tactical situations demonstrated its versatility and reliability under the most demanding combat conditions. By the armistice on November 11, 1918, over 300 Winchester M12 trench guns had been deployed with American forces, fundamentally changing the nature of infantry combat. The legacy of Winchester M12 employment during World War I would extend far beyond the immediate tactical success achieved in individual engagements. The weapon had demonstrated that innovative thinking combined with superior manufacturing could produce revolutionary capabilities that changed the fundamental balance of military power. The principles established through trench gun development would influence military technology evolution throughout the 20th century and beyond. The success of the Winchester Model 1912 trench gun represented more than tactical innovation. It demonstrated how American industrial might could rapidly transform military capabilities through superior manufacturing processes and engineering excellence. Behind every devastating blast that shattered German defensive positions lay a complex network of factories, skilled workers, and innovative production techniques that had revolutionized firearms manufacturing in ways that would influence industrial development for decades to come.
The Winchester Repeating Arms Company facility in New Haven, Connecticut had undergone complete transformation to meet the urgent demands of military production. Thomas Bennett, the company president, had recognized early in 1917 that traditional manufacturing methods would prove inadequate for the scale of production required to supply American forces with revolutionary trench warfare equipment. His decision to invest in advanced manufacturing technologies would prove instrumental in creating the industrial capacity necessary for military success. John Moses Browning, the legendary firearms designer whose innovative concepts had created the Winchester M12, continued refining the weapon throughout 1918 based on battlefield feedback from American forces in France. Each combat report provided valuable data about performance characteristics, reliability issues, and potential improvements that could enhance battlefield effectiveness. Browning's ability to rapidly incorporate field experience into design modifications demonstrated the advantage of maintaining close connections between designers and combat users. The manufacturing challenges associated with military specification Winchester M12 production required developing entirely new production techniques that exceeded civilian manufacturing standards. Military weapons demanded absolute reliability under conditions that would destroy civilian firearms. Every component had to meet precise specifications that ensured consistent performance despite exposure to mud, water, extreme temperatures, and the shock of combat use. Quality control procedures implemented at Winchester facilities established new standards for firearms manufacturing that would influence industry practices throughout the 20th century. Each weapon underwent comprehensive testing that verified mechanical function, accuracy standards, and durability requirements before acceptance for military service. The rejection rate for military weapons exceeded 15%, demonstrating the rigorous standards applied to ensure battlefield reliability. Steel production for Winchester M12 components required coordinating with multiple suppliers who could provide materials meeting military specifications. The barrel steel needed sufficient strength to withstand repeated firings of high-pressure military ammunition while maintaining accuracy throughout extended use. Receiver components demanded precision machining that ensured reliable operation under adverse conditions. The integration of supply chain management with manufacturing processes represented advanced industrial coordination. Workforce development at Winchester facilities required training skilled machinists and assemblers who could meet the precise specifications demanded by military production. Many workers were recruited from civilian industries and required extensive training in firearms manufacturing techniques. The company established apprenticeship programs that combined theoretical instruction with hands-on experience under supervision of master craftsmen. This workforce development represented significant investment in human capital that contributed to manufacturing excellence. Production scheduling for Winchester M12 manufacturing coordinated with broader American military production priorities to ensure optimal resource allocation. The War Industries Board provided oversight of defense manufacturing to prevent conflicts between competing military requirements. Winchester received priority allocations of steel, machinery, and skilled workers based on the proven battlefield effectiveness of their trench gun design. Testing protocols developed for Winchester M12 evaluation established comprehensive standards for military weapons acceptance that exceeded any previous requirements. Each weapon underwent function testing that verified mechanical reliability through thousands of firing cycles. Accuracy testing ensured consistent performance at combat ranges. Environmental testing validated operation under temperature, humidity, and contamination conditions representative of battlefield environments. Ammunition production for Winchester M12 operations required developing specialized manufacturing capabilities for military specification buckshot cartridges. Remington Arms Company established dedicated production lines that could manufacture cartridges meeting precise specifications for shot size, powder charge, and ballistic performance. The coordination between weapon and ammunition production ensured optimal performance of the complete weapon system. Logistics coordination for Winchester M12 deployment involved complex transportation and distribution networks that delivered weapons and ammunition to American forces throughout France. The Ordnance Department established depot facilities that could receive, inspect, and distribute trench guns to combat units based on tactical requirements. Maintenance support included spare parts and technical documentation that enabled field repair of weapons under combat conditions. Training integration for Winchester M12 employment required developing instructional programs that could rapidly prepare soldiers for effective tactical use of revolutionary weapons. The Army established specialized schools that combined technical instruction about weapon operation with tactical training about employment methods. Experienced combat veterans served as instructors, providing practical insights that enhanced theoretical instruction. Field feedback systems enabled continuous improvement of Winchester M12 design and manufacturing based on combat experience. Reports from frontline units provided detailed information about weapon performance, maintenance requirements, and tactical effectiveness that guided ongoing development efforts. This feedback loop between combat users and manufacturers represented advanced integration of field experience with industrial production. International recognition of Winchester M12 effectiveness generated significant interest from Allied military forces who sought to acquire similar capabilities for their own troops. British and French military representatives submitted formal requests for technology transfer that would enable production of equivalent weapons. However, American military leaders recognized the strategic advantage provided by maintaining exclusive access to revolutionary military technology. Patent protection for Winchester M12 innovations established legal frameworks that would influence military technology development throughout the post-war period. The company filed comprehensive patent applications that protected key design features and manufacturing processes. These intellectual property protections ensured that American manufacturers would maintain competitive advantages in military weapons markets for years beyond the war's conclusion. Manufacturing capacity expansion for Winchester M12 production required substantial capital investment in machinery, facilities, and workforce development. The company constructed additional production buildings and installed specialized equipment capable of meeting military quality standards. This industrial expansion represented confidence in the long-term market potential for advanced military weapons. Cost analysis for Winchester M12 production revealed the economic advantages of superior manufacturing efficiency combined with innovative design. Despite higher initial production costs compared to conventional weapons, the trench gun's battlefield effectiveness provided superior value through reduced ammunition consumption and increased tactical success rates. The economic analysis validated investment in advanced military technology. Supply chain resilience for Winchester M12 components required developing multiple supplier relationships that could ensure continuous production despite wartime disruptions. The company established contracts with backup suppliers for critical materials and components. This supply chain redundancy prevented production delays that could affect military operations requiring consistent weapons availability. Innovation transfer from Winchester M12 development influenced civilian firearms design and manufacturing for decades following the war. Technical advances developed for military production found applications in hunting and sporting weapons that benefited civilian markets. The industrial techniques pioneered during wartime production established foundations for peacetime manufacturing excellence. Competitive analysis revealed that German firearms manufacturers lacked the industrial capacity and technical expertise necessary to develop equivalent weapons within the war's timeframe. American manufacturing advantages reflected decades of industrial development that had created superior production capabilities. The technological gap between American and German firearms manufacturing would influence post-war military balance. Worker safety programs implemented during Winchester M12 production established new standards for industrial safety that protected employees while maintaining production efficiency. The company invested in safety equipment and training programs that reduced workplace accidents. These safety initiatives demonstrated corporate responsibility while ensuring continuous production capacity. Environmental considerations for Winchester M12 manufacturing included waste management and pollution control measures that exceeded contemporary industrial standards. The company implemented recycling programs for metal waste and established procedures for safe disposal of manufacturing byproducts. These environmental initiatives reflected forward-thinking corporate policies.
Technology documentation for Winchester M12 production preserved detailed records of manufacturing processes and design specifications that would benefit future weapons development. Technical drawings, manufacturing procedures, and quality control standards were systematically documented to ensure knowledge preservation. This documentation represented valuable intellectual capital for ongoing military technology development. International sales potential for Winchester M12 technology generated significant post-war commercial opportunities for American manufacturers. Foreign military forces recognized the battlefield effectiveness demonstrated during World War I and sought to acquire similar capabilities. These export opportunities would provide substantial revenue streams that justified wartime development investments. The Winchester Model 1912 trench gun represented the culmination of American industrial excellence applied to military requirements. The weapon's battlefield success validated the superiority of manufacturing processes that combined innovative design with precision production techniques. The industrial achievement demonstrated how technological advantages could provide decisive military capabilities that changed the fundamental balance of combat power. Manufacturing lessons learned during Winchester M12 production established principles that would guide American defense industrial development throughout the 20th century. The integration of design innovation with manufacturing excellence created competitive advantages that extended far beyond immediate military applications. The industrial foundation established during World War I would support American military technological leadership for generations. The legacy of Winchester M12 manufacturing excellence extended beyond weapons production to influence broader American industrial development. The techniques pioneered during wartime production found applications in automotive, aerospace, and electronics manufacturing that contributed to American economic leadership. The industrial capabilities developed for military requirements provided foundations for peacetime prosperity and technological advancement. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.